Here we have a couple of problems of the type that are called value mixture problems. And we're going to need a system of equations to figure them out. There are two things we're looking for at the end, so we'll have two variables and we'll need two equations to be able to solve for them. Let me just read the first one. It says a family has two cars. The first car has a fuel efficiency of 20 miles per gallon, and the second has a fuel efficiency of 25 miles per gallon. So what that means is they use 1 gallon of gas to go 20 miles in the first car, and 25 miles is how far they'll go on a gallon of gas in the second car. During one particular week, the two cars went a combined total of 1,025 miles for a total gas consumption of 45 gallons. How many gallons were consumed by each of the two cars that week? So let's call the two cars X and Y. So there's car X and car Y. And what this X and the Y is going to represent is what we're looking for. That is how many gallons. So this is the gallons of gas X used. This is the gallons of gas Y used. Right away, we can write one equation because they're telling us a total of 45 gallons of gas was used in that week. So one of our equations will just be X plus Y equals 45. Okay, that one's easy enough. What's the other piece of information we're being given here? Well, we have their rates here, their miles per gallon, but then we're being told they drove for 1,025 miles. To figure out an equation from these pieces of information, what you need to realize or know is that this 20 miles per gallon, that's how many miles you get out of a gallon. If one of the car goes X number or uses up X number of gallons, it's going to do X times 20 miles on those gallons of gas. So we can write another sort of sum equation here by saying 20, the rate of gas consumption, times the number of gallons that are being used is going to give us the miles that were driven for the first car. And for the second one, it'll be 25 times y. Oops. And that should be the number of miles driven, and that total was 1,025. And this is a common form of these problems. There'll be sort of a simple sum, and then there'll often be some sort of rate or value that you have to multiply by those two pieces to add up to something else. So we have our equations. Now we can go ahead and solve this. We could use elimination or substitution. Another way to solve a system of linear equations is just to graph them and find out where they intersect. So I think that's what I'm going to try with these. So let me just see if I can take these equations here and put them into a graphing calculator. The first one we had was x plus y equals 45. Zoom in here a little bit, or zoom out. So there's my x plus y equals 45. And then we also had 20x plus 25y. Oops. Equals 1,025 miles driven. Aha. So we can see where they cross. In fact, this programmer is pointing it out for us. And they cross at the point 20, 25. What that means is the number of gallons for X is that first number, 20. Number of gallons for Y is 25. So if you've got a graphing calculator and you're allowed to do that for this type of problem, it's maybe a little bit easier way to do it than to do the elimination or the substitution. But in this case, we found out that X equals 20 and Y equals 25. All right, let's try another one. And this looks a bit different, but really it's got the same form. This one says that there are two types of ticket to a show, an advance ticket and a same day. So we're going to call the advance X and the same day Y. It says the combined cost of one advance ticket and one same day ticket is $40. And for the performance, 30 advance tickets, 40 same day tickets were sold. And the total amount paid for all those tickets was $1,350. What's the price of each kind of ticket? Okay, so X represents the price of an advance ticket. Y represents the price of a same day ticket. And this first fact here, it says the combined cost of one of each is $40. So we can say that X plus Y equals 40. All right, we've got one equation. That's good. Let's see if we can figure out the second equation here. They're saying that 30 advance tickets were sold and 40 same-day tickets were sold. The total amount paid was $13.50. Well, since these represent the price, if we want to find the total price for that many tickets, we'd just multiply the number of each of those tickets by their prices. So that would be 30x and 40y, and that should add up to this 1,350. All right, let's see if we can graph that one as well. So this one is x plus y equals 40, and 30x and 40y equals 1350. All right, so I think I've got those typed in correctly, so let's look at where they intersect. And that's at the point 25.15. So the price of an advance ticket was $25, and the same day was 15. So 25 and 15. So that's a little bit of work with some value mixture problems that require a system of equations to figure out.